absolutely. So again, it just reminds you here, like my knowledge of chemistry is really better for the math stuff. These I can, look up and help you with. Did you talk about, do you know which ones you talked about in class? Because I mean, there's more than 3 that come up. Any idea what those might have been? You're muted, by the way.
Oh, sorry about that.
That's okay.
How long was I muted for?
A while. I still don't have an answer to what types of forces, if you know from class, because there's a lot here. They're given different names based on, what level of chemistry you're at.
Yeah, so I'm looking at my notes here, and I kind of missed all of last week, which is what I think that's from. So I think maybe.
All right. Sometimes they give them to you through the rest of the assignment here. Like what I don't want to do is give you the name of one that is you guys didn't talk about, because then it'll be obvious that you maybe got some help that you shouldn't
I
have.
have the slideshows though, so
That would help if you want to send that over by
yeah.
email. We can also just move on from this as well.
Mm-hmm.
And come back to it.
Yeah,
Go ahead.
because I know there's some math in here, but
We're not quite to it yet.
yeah.
We can go to 17, 18, 19 and do these, but
We need to do.
I probably should do them in order here. Let me go back and look at page 1.
I have some math too, if you would rather.
No, we can do both. I'm not trying to, like, some of this I know, like, but this I don't. This I'm not gonna be very, because it says from class. I mean, I don't want to, if I say like one of them's like London, and if you're not using those, van der Waals, dipole.
Oh yeah. Oh, okay. So it's like van der Waals, dipole, and
there's hydrogen bonding, which I don't think you guys are doing.
Well, I think that's. I think I might be the one. I'm pulling up the notes right here.
I mean, those are the 3 most common ones. Is London dipole. I'm sorry. The London dispersion forces, dipole, and then hydrogen bonding.
Yeah, we're doing hydrogen bonding, dipole, and London dispersion forces.
Okay. Hydrogen, dipole, and then London dispersion. Yeah. Okay, that's good. Now I can help you out. So hydrogen bonding is the strongest. That's usually very important to remember, usually associated with acids. Present in mixtures that contain molecules with H covalent. So it's typically H covalently bonded to nitrogen, oxygen, and fluorine. This is not a complete list of like explanation, but the strongest is kind of a keyword there.
Yeah.
Dipole. The big one is here is that the polar. Polar molecules. This is an uneven sharing of molecules.
You know what, Matthew? I'm really sorry. These are like all definitions. I thought there was more math in here.
There's no math in this.
Yeah, you're so right.
And
Let me
I'm happy to do this, but you may be better off doing some math with me and then coming back to this. Totally up to
yeah,
you.
completely. So let me send over a math project I have,
Sure.
because this is kind of, I should have looked that over better.
You will be getting like Boyle's law, Charles' law, Avogadro's law problems,
Yeah.
but that's probably like tomorrow. Of course, you know, it's never the day you need it.
Mm-hmm. Here we go. So I'm sending that over right now. So part of it's online, and then the other part is on paper. So I'll
I
send over
can,
the papers,
okay.
and then
For the online, I can make you co-host. You can share screen or you can take screenshots and send over.
yeah. So those pictures are sending, and then I'm gonna try to make a copy of the slideshow and send it to you that way.
All right, looks like you sent over something here. Take a look at that. Right, the pictures are just uploading. I really apologize for the delay. I don't really know what to do.
No, all good, all good.
It's all right. Looks like the first page is ready, so I'll grab that. Okay, I see you sent over a copy of this. Let me see if it'll allow me to open it. It should. Is it better for us to go through the presentation, the pictures? What would be? What would be best?
I think
Or,
maybe the pictures, because that's where I'll be doing the
okay,
handwritten work.
all right. All right, so the first picture here says, we're looking at scene 1.
Mm-hmm.
What is scene 1? There's nothing in scene 1. What is that referring to? Any
I
idea?
think it's referring to it's like on slide, it's like on slide 6. Like slide 1 through 5 is all like introduction, I think.
Okay. Suppose you take 2 full trips around the London Eye. How many meters will you travel at the end of 2 trips? Okay, I've got that up here. I'll snip that in.
End of 2.
All right, so the idea here is that you're going all the way around the circle once and then going around twice. That is the circumference.
Mm-hmm.
Okay, so the circumference is 2 pi r, 2 pi times 60. But then you're doing it twice. So you're going to multiply this by 2. All right, and it says round your answer nearest hundredth only at the end of the calculation. So you want to go to your calculator and do 2 times pi times 60 times 2.
2 times pi times 60. Where's pi? 2 times pi times 60 times 2. So 753 point, or it didn't say
Point,
that.
yeah, 753.98. And then I guess there's a clue. The clue comes from, I don't know, where do you get the clue? Where do you get the clue from?
I think it's on the slideshow.
Yeah, I'm looking. I see. You don't see. Let me go down there. It says
Oh,
round. Okay, we
yeah.
did that, and then
Use the
is
blue box to highlight the clue. So I think the clue is the answer. Or on the next slide, it's like n equals 754.
okay.
Oh, so depending on the answer you got, it's like different. Like,
Move the blue box to highlight. Okay. So your clue is n equals 754. All right.
and then I guess that's it for
I guess that means something.
scene 1. Okay. So on to scene 2.
Okay. Yeah. Let me. Sorry. I will get caught up here as soon as I figure out what it is
Yeah.
that's going on.
Yeah. I have
All right.
instructions.
All right. So scene 2. Got that.
Four,
All right.
six,
You
six,
got to
seven.
find the distance from A to Y. So you got to find the distance from A to X, which is a radius. And then you've got to find that kind of in between distance. Then you got to find this other one. So I guess that's the challenge here. So do all that. All right. So can you tell me what A to X is based on the given information?
Well, A to X is 8.
It is 8. Yep. And then if you just look at circle B, the distance from B to A is its radius, which is 12.
The distance from B to A
Yes.
is, oh yeah, it's
Oh,
radius.
I'm sorry. No. They're giving you diameters. Sorry. They're giving you diameters. So you have to cut that in half. Yeah, it is 12. B to A is 12,
Mhm.
which means this little piece in here is 4. Is that okay?
Yeah, that makes sense.
Circle C is got a radius of 6. And then B to C is going 12 minus the 6, which is
6.
6. So AY is 18.
8
But,
plus 4 plus 6 is 18.
but is there a reason, like, why did we do Todd versus Monk, or do we have to do both? Like, I'm asking because I really no idea.
Yeah.
I've actually never seen this before. It sounds like something from a teachers pay teachers website that they
Mhm.
use. In some cases, there is a blue rectangle provided. Green indicates, okay. Whenever you have all 6 clues, you can solve. The answer should match. Okay.
It's just so unnecessary.
2 forensic scientists have developed renderings of crop circles. Jobs turn AY for each of their sketches. Which AY is longer? That is the question. Don't trust the diagrams. Okay, so I'm looking at slide 8. So here's what you have to do. You have to read the slide first for the corresponding scene.
Mhm.
And if you look at it, I'll pull it up here and put it on the screen. There's a lot of words. All right, so they give you some background up here at the top, and then they say
Mhm.
2 forensic scientists have more background. Your job, that's what you're looking for, determine AY for each of the sketches, include which AY is longer.
Oh,
So
okay.
that means you got to do both, and one of them is longer, and we don't know until we've done both.
Okay. So XZ.
XZ.
We know that.
So that means that the radius of circle C
It's 10.
is 10. So and then the 10 is the diameter of this one. So that means the radius is 5 from B to C. So we might want to start labeling some of these. And then B to A, or B to W is 5. So
Oh
A to
yeah.
B is 2.5.
2, yeah.
So AY is 2.5 plus 5 plus 10, 17.5.
2.5 plus 5 plus 10. Cool.
So slide 9 and slide 10 are what we just did. Slide 11 is to choose
It's
the
the clue.
Yeah, so the clue is since the one on top seen, since Todd is larger, the clue is U equals 21. And then we had N equals 754, I guess.
Choose the clue on the crop circle.
Move the blue box to highlight the clue of the crop circle. Okay. All right, so you're doing that part. Slide 12.
So scene 3.
Yeah, a castle curator was astonished. We don't care about that. You want to go down to where it says, one must draw a circle with secants and tangents where the X calculates to the secret code 13. All right. So I guess on scene 3 is some sort of a circle with tangents. We'll go grab that. right, so scene 3 has a bunch of these circles. Like you see that on your paper there, there's like Sir Lancelot,
Mm-hmm.
Sir whoever, Sir another one, Sir Robin, and so on. It looks like we want the one where the X calculates to the secret code 13. I guess it's the one where X is 13.
Oh, yeah.
Does that seem right to you?
Mm-hmm. Okay. So 40 for Sir Lancelot, 40 and 4x minus 12 are going to be congruent.
Yes.
So 40 equals 4x minus 12 plus 12 plus 12. So 52 equals 4x divided by 4. X is X is 13, so it's Sir Lancelot.
It sure appears that way. Um, what does Lancelot believe the value of X to be? Does he know the secret? What does the other one believe the value of X to be?
I mean, I think that's it.
You need to do it for all of them because they want you to if you look at slide 18, it says how many knights know the secret code.
Oh, how many of them?
Yeah, sorry. Oh boy, this is awful.
So, for Sir Gawain, there's a set equation for this.
Well, we're gonna do this a little bit better. This is 9 right here because it's a radius. Do you see you're seeing my screen still? I think.
Oh, for Sir Galahad, yeah.
Yeah. And that gives us it's better to actually solve the triangle without the X value. So 9, 15, let's just call this B for the moment.
Mhm.
9 squared plus B squared equals 15 squared. This is a Pythagorean triple. But go ahead and solve that for B and then we'll get X.
Okay. What's
You have the value of B for me?
oh, I see what it's 13 point.
No. This one works out nicely.
Oh. So 81 plus B squared equals 15 squared. 225. 174 B squared. Oh, B squared equals 174. So, I mean, we're trying to find the square root of 174, right?
Okay, are you using a calculator?
Uh-huh.
Okay, 225 minus 81 is 144.
144?
Yes.
Oh, I put 255.
Okay. Yeah, that makes sense now. So B is 12. Okay. 12 is this X minus 1 side. So X is 13. All right. So this, no, I'm getting a little ahead of you, but this is where you actually go back to. So you did it for slide 13. Slide 13 is yes for the first one. Slide 14 is yes for the second one.
Okay, cool. So you just how did you get 12 so quickly?
Just the square root of 144.
Oh yeah, that's right.
Yeah. Wow.
And then so we just made x minus 1 b.
Exactly.
Okay. So yes, yes, and then circle Wayne.
Let me know when you go on to the next guy here. Circle.
Yeah.
Got it. Okay. So we're doing this stuff yesterday. It's the major minus the minor. So it's 129 minus 61 divided by 2 equals 3x minus 5.
What was that you cut out?
Yeah, did you don't forget to if you're putting this calculator, make sure you put that in parentheses first.
Oh, okay. Should I put it in the calculator just as one big equation or?
Yeah, that'd be fine.
Mm, 68 equals 6x. 6x minus 10 plus 10.
Did you get 34 here equals 3x minus 5?
I'm still doing the algebra. So 78.
Okay.
I got 13 equals x.
Yes, x is 13.
Okay.
So that's yet another one here.
That's 1, 2, 3. And then is this the same equation for Sir Robin?
It's not written very clear. Let me take a look here. I guess this 100's irrelevant. It's 54 minus 26 divided by 2 equals x.
Oh, okay. Okay, so Robin does not know the secret.
He does not.
Sir Bedivere.
All right, for the last one here, an additional line would help here to solve this. So if I add this red line in from C to the edge,
Oh, okay.
that's a radius. What's the radius of this?
12.
That's right. And it might be worth redrawing it off to the side here, where this is 12 and 16. I want you to find C. We'll deal with this stuff here, but sometimes it's better to solve a simpler problem here.
Mm-hmm.
And this is another Pythagorean triple. Does work out nicely.
144 plus 256 is 400. Square root of 400 is 20. So C is 20.
Yes. Now, what that means is the whole length is 20.
Mm-hmm.
So the equation is much simpler. 12 plus minus 2x plus
Oh, yeah.
34 equals 20. That's much easier to solve than squaring something else.
X is 13.
Yes. So I think that was 4 of 5.
4.
Yeah. So if you go to slide 18, that tells you your clue.
L equals 4.
Yeah. So L equals 4 for that one. On to slide 19, scene 4.
To build a design, 25 stone boulders or not. What? To build a design out of 25 times stone boulders.
Okay. So I'm looking at slide 20 now, actually. That first one's not really useful. This one says, though, kind of gives you what the question is. I want to confirm it with what you sent over as a picture.
Yep. How many more meters shall I need to go?
Yes.
Run to the nearest meter.
Yeah. So the idea here is that you're going the rest of the way around the circle, which is 360 minus 25 or 335 degrees.
Mm-hmm.
So the distance around the circle is 2 pi r if you're going all the way around. If you're not going all the way around, it's the angle out of 360 that you're going.
So, wait, could you repeat that? So if we're going all the way around, it's
2 pi r.
And if we're not going all the way around, it's
the angle you're going around divided by 360. So in this case, it's 335 divided by 360 times 2 pi times the radius, which we don't know. So we're going to get that in a moment here.
Oh, so we're solving for the radius.
Yeah. So, excuse me, let me go grab another snip here to make that part easier. Okay. So to find the radius, we have to use the kind of the same formula. The arc length is the distance around the circle divided by 360 times 2 pi r. So this time the arc length is 15. They're giving you that.
Mm-hmm.
The angle is 25 out of 360. And then 2 pi r we don't have. So now we can solve for r. So you want to do this very carefully because it says not to round until the end.
Mm-hmm.
I take that to mean, though, that we can round, just round out to some 4 decimal places when we're doing this. So the algebra here, it maybe looks worse than it actually is. Do you like to clear all this? Do you like to kind of divide the fraction? What would you normally do here?
I think I would multiply the 360 with the 15.
Okay, that works. So that's 5,400 equals 25 times 2 times pi times r. So 25 times 2 is 50. So you can divide both sides by 50.
Mm-hmm. 50 pi r.
And that becomes 108 equals pi r. And then you can divide by pi. So you just leave it as 108 divided by pi for right now. Or you can go to your calculator. You just want to round maybe to like 4 decimal places.
So 108 and the radius. So 34.3774.
Okay. So that's only actually be 3775. That 4 would round up to 5.
Oh yeah.
So that's where we go back to our previous equation, and that's going to go in here for r. That's the 34.3775.
And then I would just plug that in all into my calculator at once.
Yes, all at one time.
Should I plug in the 34.3775 or
Yeah.
108 over?
No. They'll give you the same answer. It actually kind of works out nice.
Oh, okay.
Just I'm surprised by, but that's what this was designed to be.
Okay, I got 201.
Yes. No, it says that that is your value of K.
Okay.
There's other ways to do this, your friends may do it slightly differently, but
Uh-huh.
this works.
Nice.
All right. Scene 5. We're up to scene 5.
Oh wait, 1 second. Oh. Do you see like a clue or something or?
You just write K equals 201.
Oh, okay.
That's your clue.
Scene
All right,
5.
scene 5. So you need to determine the measure of an angle AB, or I'm sorry, arc AB. And we can do that here pretty. So the x plus 12.5 is this one right here. 2x plus 47.5 is this other one. They both add up to 360 because you're going around the circle.
Mm-hmm.
So you're going to set those equations. You're going to add them up. X plus 12.5 plus 2x plus 47.5 equals 360.
360. I got 150 for X.
150 you said?
Mhm.
So it should be 3x plus 60 equals 360. Subtract 60 from both sides, 3x
Oh,
is 300. X equals 100 is what I'm seeing.
yeah. I left it as 2X on accident. Measured AB.
So to find that, you've got to put X back into the,
100 plus 12.5.
yeah,
100, 112.5.
good.
Tea time.
You got, so for T times, same thing, 5x plus 7x adds up to
360.
360, yeah.
X is 30.
Yes, and so you can use that in the
AB. So
equation, 5 times 30.
150.
All right, and then we got to go figure out like, well, what does it want? Does it want the, oh, it just wants the one that's the greatest. So the greatest is the one at the right. And then let's go see what that corresponds to.
Tea time.
So that's O. O is 150.
Measure of the longer minor arc will be equal to O. Is cool.
It doesn't look like there's anywhere to type in your K, I guess, on scene 4,
Yeah.
but you got that down. Okay. Up yet another scene. Okay, we'll see how far we can get here.
Mhm.
Use a compass to sketch the circles on the graph. Okay, that may be a kind of a by hand thing. Let me go look at your other picture.
I think, yeah, I'm pretty sure it is. Oh no, there's a graph.
There it is. Okay. Let me snip that in real quick. We're gonna run out of time here pretty quick, but I'll see how far we can get on this. Do you know if we're meeting tonight or is it your brother?
It's my brother.
Okay. So the center is at, what did it say there? 7, 7, radius 3. 1, 2, 3, 4, 5, 6, 7. All right. So it looks like it's right there, radius 3.
Right above the, yeah.
I don't know if I've got this one right. 1, 2, 3, 4, 5, 6, right there. Okay. And then you're going up 3, down. So you're going that way.
The diameter is endpoints of.
Yeah, so it looks something like this. And then you do the same thing for circle F and so on.
Oh, the radius is 3, so.
Yeah, radius is 3.
Go
Fortunately, do
3.
have to stop here, Hector. I know it's kind of
Yeah.
got a late start, but
All good.